welcome back. Lecture 53 would be on urban freight planning, and we will focus on the logistic aspects. The different concepts that will be covered, we will talk about the background of how urban freight planning and management is connected with logistics. Then we will do freight flow estimation using logistic cost optimization model. Then we will look into regional freight flows using input-output analysis. And finally, we will look into the transshipment logistic as well as the transshipment problem. So, logistics include different kinds of activities. For example, the entire supply chain is actually controlled through logistics. So, planning and implementation of the movement of the raw materials, inventory and finished goods from origin to destination, this entire thing is controlled through logistics operation. Logistics also include inventory control, material handling and the ordering processes. That means the back order office processes through which you do ordering and determining of how much quantity. All these things are determined also at the within the broad gamut of logistics. And then plant and warehouse selection, and where to which plant or which warehouse to select to get the goods from or to deliver the goods from. And then mode choice, what kind of vehicles to be used, and then warehouse and storage decisions like where should we have our warehouses, where should we have our storages. All these things could be also decided within the gamut of logistics. So, logistics is a broad term which actually covers all aspects of supply chain management. So, so sometimes all the decisions that we just talked about earlier, this could be all individual decisions, or it could be decisions where it could be jointly taken. For example, choice of mode and choice of storage location may be probably linked, or choice of like the amount of the inventory that I am going to move and the kind of mode that I am going to use is also linked. So, that means this could be also joint choices, as we have discussed in earlier lectures, that we can take individual decisions on certain aspects, or we can have joint decision between multiple aspects which influence each other. So, when we did freight modeling in the when we covered freight modeling in the previous lecture, we were trying to determine the kind of freight flows that happens in an urban area. But what we didn't talk about was selection of distribution centers, warehouses, and also intermodal terminals. So, these were not discussed at all. So, we understood that there is a point where there is a demand, and then there is a point from where the demand could be supplied, and we were trying to determine that how will this demand will be distributed among the total vehicular flows will be distributed between these 2 points. So, same as a trip distribution model, we said that we can use gravity model for determining how much amount of goods will flow from one zone to another zone. Now, the question is, these decisions are not that simple, because some of these decisions may involve intermediate warehouse, or it could be a distribution center. Then there could be many distribution centers in that particular region, and then how to do my distribution is not that easy a task. So, that is where this logistics parts comes in, and the basic concept of logistics is to actually reduce cost. So, reduce cost either by changing the volumes from that has to be sent from one point to another, or by also changing the location of those distribution centers, or it could be the size of the distribution centers as well. So, these are the things that actually influence the entire process of distribution, and that actually has to be also considered when we do our freight modeling, because this distributing the goods as per the gravity model is a broad estimate, but if you really want to get into details of it, we have to get into this transshipments as well as the different optimization models that are used to determine the best possible distributions and supply chains. So, incorporating logistic decisions in the freight modeling framework is challenging. Of course, it is challenging because most of the choices and the parameters guiding these choices are all specific to private organizations. That means all these choices are made by private organizations, and in rare case they will be willing to share the data. But as we have discussed earlier, that ULB, because it gives licenses and does the registration, they can make it mandatory to share some of this data, and we can always do some amount of service to also get to come to the point to understand what kind of distribution structures this particular company follows, or this particular type of goods are using in that particular urban area. So, one of the very basic models that is used in this supply chain is economic order quantity model. So, we can actually use this particular model to also determine freight flow in an urban area. So, this so the logistic cost optimization model, or in this particular case one of this is the economic order quantity model. This actually helps us to determine what are the optimal lot sizes. Now, what is a lot? A lot is basically the number of units that a company should add to inventory with each order. That means it's the size of the shipment that we are talking about. So, a company or a warehouse or a distribution center or something of or anywhere where there has to be some supply, it only takes place when there is there is material to be replenished, and also there is a cost of holding that particular material at that particular location. So, if I store too much goods, that is of no use. So, at the same time, if I don't get the goods when there is a requirement, that is also of no use. So, we have to balance this. So, that is where this particular equation comes in, this particular model comes in, and when we use this model, we can also determine that what amount of goods has to be transported between these different entities in an urban area. And once we know the type of goods that has to be transported, from there automatically we can generate the kind of traffic load or the freight load that it would generate. So, cost optimization is the basic fundamental principle that is followed in logistic industries, any industry for that matter. So, the total cost has to be optimized, and this optimal lot size for our industry can be determined based on its annual demand, ordering cost, holding cost, and the cost per item. So, this cost per item is the variable cost per item to, of course, store the item, and holding cost is the fixed cost of holding, like I have a warehouse, there is a rent for that and so on. And ordering cost is the price of these units, and those annual demand is the total demand. So, fixed quantity is ordered each time the inventory level reaches a specific reorder point. So, I may see that there is based on the demand, there is a slope that is generated that this is the rate of diminishing of my quantity. So, at one point we can decide that this is the point of reorder, and we can actually reorder whenever the inventory level reaches that order, we can place a order for replenishing that my inventory levels. So, the lots fix, and usually we'll try to determine the fixed quantity that has to be ordered each time. And this fixed quantity is because we want to standardize the transportation. We don't have to do a variable amount of transportation at different point of time. That actually increases cost. So, if the transportation demand is fixed, then automatically I can make a contract for an entire year or for a longer time period, so that we know that every month or every day so many amount of trucks would be required, and accordingly my the company can buy its own trucks, or accordingly it can give an order to a particular other entity. So, it basically economizes the entire thing. So, the lot size determines the type of vehicle used for delivery and the number of yearly shipments, and this exercise for the all economic units will generate a fair distribution of freight flows in a region. So, if I have different economic units and I can determine that what kind of quantities they are ordering, like a retail store how much they are ordering, or how much it is company is ordering in terms of raw materials and so on, automatically I know what kind of freight flows will be generated. So, this economic order quantity, or rather I would say Q, which is the optimal lot size, is equal to 2 ds divided by HC, and we have to take a root of that. So, what is this D? D is the annual demand, and S is the ordering cost per lot, and H is the holding cost, and C is the cost per item. So, C is basically the varying cost, that is per item for this ordering. H is the holding cost, that is the fixed cost for ordering. S is the ordering cost per lot. So, this is for that particular group, and D is the total demand. So, we will try to this using this formula we determine the optimal size of the lot, and then we can also have a modified model where we can determine n, which is the ordering frequency, and dn is the d1, d2, d3, dn is the total demand for the nth item, and similarly C1, C2, C is the cost of the nth item, cost of the nth item. So, if I have, we can also do it in this way, d1 into C1 into h, and then we can sum it up divided by 2s, and again we take a root of that. So, that will actually tell us how many, what is the frequency of ordering as well. So, both these formulas could be used to determine the total number as well as the quantity of order that has to be served, and from that we can determine what kind of freight flows would be generated. So, this is one way of approaching, rather to determine what kind of truckloads or the amount of vehicles or freight flow would be generated in an urban area. So, we did this 4-stage model, sort of 4-stage model that we covered in the last lecture, the commodity flow model, the truck based model, the commodity based model. So, this is another approach we can say. So, the next approach that we will talk about is the input output analysis, and this approach is mostly taken at the regional level, because in many cases we do not have very detailed data on that is required to determine this commodity flow models or this truck based models in a bigger scale. So, that is where we will depend on certain other kinds of analysis, and this is where the regional freight flows are determined using input output analysis. Now, before I go any further, I have to first explain what input output analysis is, and input output analysis was first proposed by Vasily Leontief, and he got a Nobel Prize for that. And what he said was, the input output model represents the interdependencies of various sectors in a national or regional economy. So, this model actually shows that there is dependence between the different sectors and also overall consumption and so on. So, I will come to that, but basically if I have 10 sectors in the economy, so each sector depends on another. So, that also means that if I want to increase production in one of the sector, I have to increase production in all the other sectors which contribute to this particular sector. So, if there is also a consumption along with that, so the consumption is basically the total amount of goods that will be produced by a particular sector is the total amount of goods consumed by other sectors plus the consumption for that particular economy. So, our consumption again will include that direct consumption, then export, import and all these other things. So, that is what is shown in this particular table, where A, B, C, D, E are the different sectors, and this the row level, suppose over here it shows us that the output of sector B in tons and how much of it is used by the other sector, like 10 tons is used by A, 20 tons is used by B, 15 tons is used by C. So, this could be tonnage, this could be in cost, this could be in many other units could be also used. And then the column C shows the input in tons from various sectors required by it. So, if I look into this column C, so I see that what amount of goods are required by from other sectors, like I require 35 from A, 15 from B, I require 0 from my own. But in some cases, if I am producing electricity, I may require some electricity to also produce electricity. So, that means there will be some value over there as well. So, this is 30 from D and 20 from E. So, that is what this table shows, and we just discussed that to raise production in sector C, the production has to be raised proportionally in the sector supplying to C. So, that means there is a proportional relationship between the different sectors. So, this is a input output transaction table. This is how in actual calculations this kind of tables are actually used, but this is one variant of the table. There could be many variants of the table. So, over here you can see that there are several sectors that are given there, like agriculture, mining, construction, manufacturing and so on, and then there are different sectors over on this side as well, the same sectors of course, and here we can understand how much of agricultural production goes into agricultural, mining, construction, manufacturing, trade and so on. So much of that goes into this, plus Production in agriculture also goes into personal consumption, it goes into gross private domestic investment, then how much of it is purchased for investment, like people may want to store some grains, and government purchases of goods and services, and then it could be also export as well. Then mining, same way we can also estimate, and so on. So in addition to all this, we can also have some value added services like employee compensation, profit type income, indirect business. So this actually adds up to the total amount of value that is for each of these sectors. We can also say that, okay, out of when we are measuring the economy, we can also say how much amount of money is being generated and how much amount of production is in terms of both money. So it, and also a number of employees that are being compensated, that also becomes part of that, and overall this could be used to determine the gross domestic product of an economy. So Leontief made a huge table of maybe around 500 and sectors and so on. So similarly, we can do this kind of tables also for industry specific. For example, this is like sector specific. We can also make it like industry wise. We can follow the same procedure. So we will know that, okay, what amount of goods goes from one industry to another industry. Probably that would be good when we do analysis of the freight required as well. So this is the basic input output transaction table, and this kind of data is also available. So now how do we relate this transportation with this particular input output analysis? So transportation demand is derived from economic activity, that we all know, and industry will need a supply of intermediate goods to carry out production, and this produced goods will need to be transported for further processing or for final consumption. So that means whenever there is requirement of a good, there is also requirement of a vehicle to transport it. So that is how transport is connected, and demand for freight is basically generated in two stages. The location of industries under various sectors along with the input output table will help in ascertaining regional freight flows, and the final consumption and corresponding freight is assigned based on population and its respective GDP. So final consumption is basically also depends on the total population and the GDP of that particular area, and the future demand for freight is intrinsically linked to GDP growth and growth of different economic sectors. So that means if I know if there is a target of around 7% growth in the GDP for the next year, that could be used to determine what would be the growth in the different sectors as well as the growth in this freight traffic as well. So we have to estimate from macroeconomic estimates. We are now getting into these estimates of freight and other, the freight flows, and also the amount of vehicles that will be needed to support this kind of freight flows. So this is this gives us a different perspective altogether. So we are looking into the entire this process from the macroeconomic perspective, and so it is not we are concentrating on each manufacturing industry separately, but at the same time we require data of commodity flows from different sectors, and then eventually if we want to go in further detail, it has to be as per particular industry as well. So just to show you an example of how other the interdependence between freight and other sectors of the economy. That means if I consider freight also as a sector of the economy just for the time being, and so there is demand for transportation services because there is the rest of the economy, means all the different sectors, that leads to demand in transportation services. And then there is supply of transportation services and infrastructure. Based on the supply, if there is enough supply or not, lot of things change. That means if there is enough supply, then prices would be within control. If there is not enough supply, then prices will go up. And when prices will go up, it will have a chain effect in all the other part of the economy as well. What kind of effect? So some of this effect, like all the effects are listed over here: income effect, price effect, market share location effect, or system wide effect. So what is income effect? Income effect is change in transport cost will affect the production of other goods. So this is the first effect. Then price effects. change in transport fares or delivery charges will affect the cost structures of industries and the choice of consumers. So, we always say that whenever the price of freight increases, like suppose there is an increase in fuel price, immediately transporters will say we will increase cost and all, and as soon as that is done, the prices of goods rises in the market. So, that is the first thing. Now, when prices rise, then there is obviously the market actually rearranges itself. That means the supply and demand, all these things rearranges. So, based on the price of a particular good, it would be demanded by people, right? So, if suddenly some things will increase higher, some prices will not go up that much high. So, it all depends on that. So, market share effect is change in shipping cost can lead to modification of the regional distribution of supply and demand. So, this change in freight price will also change to supply and demand of the entire area as well. And finally, there is system-wide effects such as and also this market share effect also will help us to determine, well, if there is supply demand changes, then my choice of warehouses, my choice of transshipment, all these things will also be affected. So, finally, we have system-wide effects where change in system characteristics like congestion or link velocity will also lead to system-wide effects. So, these are the different ways freight actually influences the economy. Now, coming back to the input-output table as we just discussed earlier. So, the underlying assumption is that that the inputs used in production are proportional to the output. So, that is given by this formula Zij is equal to Aij into Xj. Now, Zij is the inter-industry sales from sector I to sector J, that is either goods that are transported from or sold from sector I to sector J, and Aij is the technical coefficient, I will come to that, and this is the proportional coefficient you can say, and then Xj is the total output of sector J in monetary terms. So, a part of the total production of sector J is and that is being sold from sector I to sector J. So, that is what we are determining over here, and to explain it to you with an example, we can say that like from over here we have two sectors, one is steel and coal, and then again from this steel and coal on this side as well. From steel to steel there is 1000, we can say $1,000 or 1000 INR, 1000 lakh INR of course, something like that. And from steel to coal around 2000, this kind of amount of goods are actually being sent or consumed. And within steel, steel takes values from steel itself and also from coal. Coal is 200. So, we can find the proportions that is done over here. Aij is basically the proportion. So, here 1000 divided by total of this particular column, which is 3000. 1000 by 3000 is the formula. So, Xj is 3000 and Xj is the total output of sector J in monetary value terms, and this Zij is inter-industry sales volume between sector I to sector J. So, that is how we arrive at this figure, and now this 1000 to 3000 we can, this is just given a proportion. So, we can put it in decimals as well. So, this becomes a coefficient matrix. So, we can write it in the matrix forms as well, where we can say that okay, this value 1000 by 3000, then 2000 by 2500, and then 2000 by 3000 and 500 by 250. So, we can write it in this matrix forms as well. So, I will show you an example. So, a city has got three industries, namely coal, steel and electricity. To produce one INR output of coal industry, so this is where we are listing the proportions. One INR output of coal industry requires 0.3 worth of steel, INR 0.3 30 paisa worth of steel, and INR 0.40 paisa worth of electricity. So, that we can list in this particular form, where we can say that okay, for just ignore this CSE, we can also have CSE on this side as well, like the table. So, this in matrix these values are not there, but just to give you a perspective. So, we have 0, that means coal is taking 0 from coal, but it is taking 0.3 worth of steel and 0.4 worth of electricity. So, that is given here. So, because it is based on INR 1, we are using the 0.3 and 0.4 directly. So, it is a proportion we can say. So, for steel it is produce 1 INR output of steel requires INR 0.50 worth of goods from coal, INR 0.10 worth of steel and INR 0.30 worth of electricity. So, 0.5, 0.1, 0.3, and similarly for electricity we have 0.3 worth of coal, 0.2 worth of steel and 0.3 worth of electricity. And then how much should each produce to meet consumer demand of INR 20,000 worth output of coal, INR 15,000 worth output of steel and INR 18,000 worth output of electricity. So, this is the consumer demand part. This is 20, this is all in thousands, then 50 and then in 18. Now, if I go back, so over here this is that consumption part. So, this is D. I will say this part is D. So, whereas this part are the different sectors. So, D could be a combination of different things, but here we are using one value. So, that is why we are listing it like over here 20, 15 and 18. So, this is D, this is the total consumption, and then coming to the example. So, this is what we just showed you, and then I can write this in write X is equal to total output of coal, Y is total output of steel and Z is total output for electricity, and so X is equal to 0 into X plus 0.5 Y plus 0.3 Z plus 20 and then plus 20. So, this X is the total output of coal. So, that output goes into coal, output that goes into steel, output that goes into electricity plus the total consumption. So, we have got 3 equations and this is equations we can write and this needs to be solved. So, this could be solved using matrix form and this could be listed again in this particular way. So, we need to determine X, Y and Z and this could be listed. So, this is the form that we have already seen here and we take this X, Y, Z is also here. So, we take those out and then we have this additions of 20, 50, 18. So, this is the form that we can use to write this, and to solve this we say we can, again this in the matrix form becomes we use this X equal to Ax plus D. A is this one, this is X and then this is X and this is D. So, then X minus Ax equal to D, then I can take a identity matrix and 1 minus I can take X common and then this becomes the identity matrix 1 minus A into X equal to D and this X equal to 1 minus A inverse and then D. So, we can take identity matrix minus A and then the inverse of it and then multiply it with D and then we will get the value of X. So, if I solve this, I will be able to get the value of coal as INR 85,000, steel as INR 68,000 and electricity as INR this 103 this 1,03,400. So, this is how we can solve it, that is total amount of production that is required, and based on this total amount of production we can actually determine that, and based on this particular values we can determine what kind of total trucking will also freight will also be generated. Now, coming to that part. So, we had this already Zij equal to Aij into Xj. So, this Zij is the inter-industry sales from sector I to sector J, Aij is the technical coefficient, the proportions, and Xj is the total output of sector J. So, we just discussed that and we revised when we revise it in the matrix format it could be written as X equal to Ax plus Y. So, where X is the output matrix like we just saw, A is the technical coefficient matrix and Y is the final demand vector. Now, this is the final demand. So, last time we used only a single figure of consumption by the consumers, but A could be also where this like for example, this Y could be like C I plus E minus M, where C is consumption, I is investment, E is exports and M is this imports. And this could be also done for every year as well. So, we can have Y expanded as well and this could be taken from the transactions table that we saw earlier. So, this revised final matrix format we need to determine as A is the change in percentage in final demand, a change in percentage in final demand creates change in all the other sectors. So, that means if I change this Y, this is the final demand, then there would be also change in delta X. So that means the revised final matrix format representing the changes could be given like, just we take the delta value of that. So this remains as it is, and this is delta y. So any change in y will lead to change in x. So this where I is the identity matrix, of course. So the demand for transportation mode at a given future time t plus n will be given by x for this time period t plus n is equal to the same identity matrix into y into t plus n. So y, where y is the final demand vector whose components are all this we have discussed. X10 is the total requirement for transportation mode T1 necessary to meet the final bill of goods y t plus n. So this is how we can also determine transportation requirement based on input-output analysis. Now we look into another major problem or another major area of logistics, that is transshipment. Now transshipment involves shipping of goods or containers to one or more intermediate destination before the final destination. So till now we were discussing that okay, there are so many sectors from this sector. From sector 1 the goods go to sector 2, and sector 2 it goes to 1, or from 1 to 3 and so on. So we are talking about direct shipment. So that is, of course, that happens like from example from a company it may directly ship to a particular retailer, but usually it is not like that. So there are, of course, in middle there are warehouses, then there are distribution centers, then there are other kinds of areas where this where there has to be some amount of storage or some amount of consolidation, or if I am talking about the transfer of goods, then there may be also change of the mode as well in between. So this transshipment happens to facilitate all these aspects, and that actually leads to reduction of the total cost. So that means like consolidation, there are certain things called urban consolidation centers. Now what are those? This I will discuss that, but basically these are centers in an urban area which are actually suppose Amazon is delivering in a particular city. So it may develop consolidation centers at certain zones of the city, and that means lot of goods will come to this particular zone, and from there it would be one person will be able to, or many delivery person could be taking these goods from of these different kinds of goods, and then they are delivering it to different houses. So this is some form of consolidation, because we are taking goods from so many companies and then sending out delivery people who are delivering goods from different company to different consumers, but they are all consolidated. Right. So this is one type of consolidation. Then there could be something like one company sending goods to a particular distribution center from where it is distributed to the different markets. So that is another form of consolidation, or rather we can send big truckloads to this particular distribution center, and from there we can break it, and then we can break the bulk, and then using smaller vehicles we can deliver to the different markets. So this kind of transshipments occurs frequently, and it actually increases the reduces the total cost of this total supply chain. So the reasons for are consolidation, mode change, change in means of transport. Sometimes what happens, you are using trains to deliver it to a port, and at port it again gets repackaged, and it gets repackaged in a dry port, and then again it is loaded into the ships and sent to a different country altogether, or maybe another part of the country as well. So that kind of changes also happen, and then break and bulk, of course. So these are the different kinds of transshipments that are possible. Here we see one example. There is a sender. He uses road or rail transport. It goes to the dry port. It's sort of a container terminal where all the there are custom clearances, then there are spaces for trucks, services, washing facilities, and so on. There are consolidation happening, high capacity cargo storage, high capacity mode connections, all these things happen over there. So trucks come in, but multiple trucks could be combined into one container, and the container is then loaded into the ship. It goes into the ship, and then it is transported via sea. Then it goes to another port where there is another dry port, where all this again goes back from bigger containers into truckloads, and these trucks actually goes and sends it to the receiver. So this kind of change also happens. So there are different forms of transshipment that is there in the supply chain. So that means whenever we were doing earlier freight modeling, Once we know the total amount of commodities that would be transferred from one zone to another, we also need to understand, will it go directly or will it go via a transshipment center, or via, will it be there will be transshipment in between. That means, will there be an intermediate distribution center or a warehouse or something like that. So again, these decisions are taken by private entities, so it's very difficult for somebody outside to understand what exactly what supply chain is being followed. But more or less, through surveys or through other form of data collection, we can get to know about that. And if I optimize those values, then automatically I know that probably the company is also following the same model. So we can either simulate that, or we can get to know from the company what kind of models they follow, and we can apply similar models to also determine the kind of freight flows. So if we do it like that, then only the freight flows that I will predict would actually match with the urban freight flows that we see on the streets. So this is one part of this freight modeling, which is totally different from this passenger modeling. So this also needs to be considered. So transshipment, when we talk about transshipment, there are different forms of centers, like there are integrated freight complexes. These are located at the periphery of the urban areas. They serve as a point of wholesale trading, handling and distribution of regional and inter-urban goods, and they provide facilities for servicing as well as for parking of freight vehicles, and they are connected to the city by a road network. So this is one form of a goods exchange center, you can say. Then there is an inland container port, we already discussed that, and they have got facilities for not only for this kind of operation where cargo is received or dispatched after stuffing or stripping of containers, but also it got facilities for custom clearance, facilities for cargo storage, repair, container repair, and so on. So this kind of facilities also provides these are logistic centers, we can call it, and many of these also have got these offices for the logistic companies as well. So then we have got truck terminals. This is the interface between intercity and local transportation facilities. So bigger trucks come from the all over the country to this truck terminal, which is near a city, and from there, because the city will not allow larger vehicles to go in certain routes and certain corridors, there it is transferred into smaller trucks, and then it is transported to the warehouses or retail points or distribution centers in those particular parts of the city using those smaller trucks. So that is the purpose of a truck terminal. So this is the point of break of bulk of goods, and facilities for location of transportation companies, vehicle servicing, idle parking is also could be there. Warehouse is a little different. It serves as a temporary storage for goods for onward transport to customers. So it is a place where the supply demand is also balanced. Like the production rate and the demand rate may not be same. So that means this is where it can be averaged out, because production, if I match it with demand, then maybe we will end up with a lot of extra investment, because we have to invest in more machineries and so on. But if we keep on continuously producing all throughout, and then we supply it, we store it and then supply it as per the demand, then probably it reduces cost. So that is why a warehouse actually is required. Then we have got urban consolidation centers. We already discussed that. It serves a specific geography area and where to which multiple companies deliver, and goods are destined, that goods would be then distributed in that particular area. And it is more smaller and more environmentally friendly modes of transport could be used for distributing the goods. And then there is another concept for something called truck turnaround time. And when we do our models, we also have to consider this as well, where a high turnaround time increases congestion and cost of freight transport. So that means we have to lower the turnaround time. So whenever there is a vehicle coming in, so it gets inside from warehouse, it comes to this particular place, and then there is a gate. Then there is the empty vehicle comes in. So this is unladen weight, tare weight we call it. Then it is loading. Then the gross weight is measured. It is invoiced. Then it goes out of the gate. So this is the total in plant turnaround time. So this is where the truck gets loaded. and then it goes to the warehouse or wherever it is going, it unloads itself, then it goes to other warehouses and then again comes back. So that is en route turnaround time. So this is how turnaround time also, the total amount of time spent in loading, unloading and doing those movement except for the travel, that part also has to be reduced. So that could be also optimized as well. But in any way, so in freight modeling, we can whenever we are doing this kind of estimates, there has to be this kind of values has to be got from survey. That means we have to survey the people and ask them that okay, how much time they take for loading, unloading, or for in the plant, how much time they have to spend in queue with other lorries and so on, and this has to be also included in our models. So when we look at this transshipment, instead of direct deliveries, transshipment is a delivery via another point. So this is called, this kind of problems could be solved mathematically as well, and this is called a transshipment problem. This is a problem which is almost similar to the transportation problem. That is another linear optimization problem. And so transportation problems are actually solved by converting it into our transshipment problem is solved converting it into a transport problem. So we will learn to solve transportation problems in the next lecture. So just to give you an idea, so we have got origins and A1. So origin is a big A1, A2, A3. These are the origins to AN, M, and A and AI with available quantities on offer is AI. That is, these are the total quantities for A1 offers A1 available quantity, A2 has got A2 available quantity, and so on. So transshipment point SK, this is transshipment point SS, and it has also got quantities SK. So that means each transshipment point will have different quantities to offer to further destination. So it could be also the total amount of storage that is there in this total transshipment points. And destination Bj is with demands Bj, so small bj. So this B1, B2, these are the destinations, and small b1, b2, these are the total demands in those areas. So xik is the quantity transported from AI to Sk, xjk is the quantity transport from Sk to Bj, and Cik is the transportation cost per unit of goods from AI to Sk. So these are the different costs, and finally we have got the cost for warehousing cost. That means more amount of goods that are stored in the warehouse Sk, the more is the cost of warehousing. So this total cost has to be reduced. So there is transport cost from this point to this point, transport cost from this point to this point, and there is also cost for storage over here. So overall this has to be minimized. So this could be formulated as the following linear programming problem, where we minimize T is the total cost, where we have Cik into Xk, so and then Cjk into Xjk, and we also have Ck into Xjk. So basically these are the different costs for transporting goods, and then these are the cost for this is the total amount of Xk, as we have seen, is this is the Xij is the total quantity transported, and Xk is the total amount of goods that is being transported from over here. So that is how we will come to this point, and we have got several constraints. So these are mostly this supply constraints and demand constraints, and then there is also holding constraints in the particular warehouses. So we will solve this problem in detail in the next lecture. And transshipment problem is solved first by converting it into a transportation problem, and this problem would be used to determine location of terminals, warehouses, and consolidation centers. So location, that means the total distance that has to be traveled, that is this incorporated in the cost. Cik and Cjk are the two costs from this origins to the transshipment center and from transshipment center to the destination. So this two has to be actually this cost actually will, based on the location, this cost will vary. So if I have 3 locations and I am trying to find out which will give me the lowest cost, then we can run this optimization problem for this including these 3 options scenarios, and we can say that this particular location for the this transshipment center would be probably preferred. So this we can determine the location of the terminals. The problem could be also used to determine optimal flows. So we will be able to say what kind of flows happen. Xjk is a flow, these are the different flows that are there, and Xik is also a flow. So these are the 2 kinds of this Ik and Xjk has to be estimated. This would be Ik, I guess. This would be Ik. This is Ik, and this is Jk. And this is the Ck is the total cost of this storage. So total amount of things stored is also we can also determine the amount from the amount of goods that are transported. So this problem can be also used to determine optimal size of transshipment points. So this Ck actually can, this is the cost of goods to store over there. So this could actually determine the size, what size of this particular location could also be, so it's the location as well as the size of this particular transshipment center that also could be determined. So based on that, a company can make an investment in an urban area to buy warehouse space or to rent warehouse space. So this is how the transshipment problem could be also solved. So these are some of the references. So these are common references which you can use for this entire this lecture as well as the subsequent lectures. To conclude, logistic decisions are gradually getting incorporated in the freight modeling framework. Freight flows can also be established using logistic cost optimization in an urban area, and this could be an alternative to the gravity model. This we already discussed. Freight flows at the regional level is determined using input-output analysis, and that is the best way to analyze in the regional scale. And then transshipment is an essential component of logistics, and this could also be considered while determining freight flows in an urban area. And this is particularly significant due to the growth of e-commerce. So we need to consider transshipment as an essential part of this entire logistics, and then we in our estimates of how things are delivered inside an urban area, we need to consider transshipment. Otherwise, we would make wrong estimates of how products travel from one point to another. Thank you.